All right, so here we are, build, day one. I'm Gavin Gear.
I'm Brian Rockwell.
And we both work on the team in Windows that's working on AllJoyn and working with the AllSeen Alliance. We're excited today to talk to you about the work that we've been doing with the AllSeen Alliance and with our partners. Just a brief note, at the end you're going to have an opportunity to send us your feedback. I'll put this QR code up again at the end, and we would really appreciate it if you would take the time to submit an evaluation and give us your feedback. So about 5 years ago, I set out on a mission that I thought would be fairly straightforward. I wanted to build a home entertainment system that would use a single remote, that would be cost effective. I didn't want to spend as much on a remote control as I would on an Xbox. And it would also be easy to set up, easy to maintain, and easy to use. And being the obsessive person that I am, I set out into a binge of analysis paralysis. I researched just about every component on the market. And in the end, I got close to my goal. I used an Xbox 360 remote control. I used a surround sound system and a TV from Panasonic that both used Viera Link to communicate with each other, and life overall was good. I couldn't power down the surround sound system, and I did have to switch inputs on the remote control.
No, Gavin, I'm not nearly as obsessive as you are, nor as compulsive. But I looked into this, same as you, about the same time, but I quickly backed away from it. It just seemed, it's complicated, it's expensive, really jumbled up. The technology didn't really seem to be there. It seemed like a little bit of a wasted opportunity.
Well, I also have kind of devolved into the basket of remotes scenario. I decided I was going to try an Amazon Fire TV, which of course uses Bluetooth, and then I've got everything else on infrared. And in frustration, I've thought to myself, how could it be 2015, this day and age when we've put a man on the moon, we've connected the whole world with the internet, we're just on the verge of being able to 3D print replacement body parts, and it still takes me 3 remote controls to watch TV.
There's just so much potential for all these scenarios of interoperability and all these devices working together. This area is just exploding. So many new devices are being created each day.
And the opportunity is definitely profound. The IDC is predicting in the next 5 years, we're going to have 28 billion connected devices. That's 4 connected devices for every man, woman, and child on the face of the earth. But where there's huge opportunities, there's also huge challenges. This example here is just, the end result of some of those challenges. What we're here today to talk about is AllSeen and AllJoyn. This is a technology that was created to address some of these huge challenges and to help remove some of these huge barriers. Being developers, we want to give you guys and you all a sort of AllJoyn 101 so that you can understand what AllJoyn is, what the different platform components are, how they work, and then
how you can actually bring them into Windows. So we've spent some time in the past year bringing AllJoyn into Windows. We want to explore some of the reasons why we did this, some of the benefits that this gives us, as well as get you guys up to speed so you can go out and make the next great Internet of Things app. We'll tell you how to get involved with the AllSeen Alliance, move forward, potentially contribute your code back, and help drive the future of IoT.
So that's, in general, what we're going to talk about. Quick question. Who here has heard of the AllSeen Alliance and knows what the AllSeen Alliance is? Wow. That's pretty impressive. So the AllSeen Alliance is basically the organization that is a consortium of hundreds of companies that have come together to help evolve the future of the Internet of Things. It's run by the Linux Foundation. It uses some of the people and the resources and the structure from the Linux Foundation, but really AllSeen Alliance is the organization.
Yeah. AllJoyn is the result of the collaboration between these companies. It's actually the code base and the source. It's an open source and cross-platform. Any developer can use it to enable their apps and their devices to be internet connected.
So the example that I gave of my home entertainment system was really just a small view into a much larger problem domain, the problem domain of the smart connected home.
Yeah, the technology to connect these different devices has already existed for many, many years, but a lot of them are trapped within concrete verticals in their walled gardens. It's either within an iOS or in a OS, within a manufacturer schema, but they're all locked down and they're hard to access.
And viewing this from an app developer's perspective, there's really a lot of surface area. You know, you've got different protocols, different APIs, a lot of different scenarios to provide support for in your application, and it's a moving target. You never know when another manufacturer is going to release a new protocol, another way to integrate, that sort of thing. And in order for these scenarios to become mainstream, these problems have to get addressed. We've got to make it easier for app developers to provide ubiquitous support for this new Internet of Things, this whole world of devices that's going to proliferate. And AllJoyn, actually, it was created with that in mind. AllJoyn provides the necessary means for devices to expose standard interfaces. It provides applications, standardized means for being able to discover, connect to, and control these devices.
So AllJoyn supports the platforms that all IoT operates on. It's on the most popular consumer OSs. It's on all of the most popular manufacturer OSs for making embedded devices. It doesn't matter where you write your app. It could be iOS, Android, or Windows. And it doesn't matter what system it's written on, whether it's Windows IoT for small devices or it's embedded Linux. All of these can interop. It's open. It's the promise that we're trying to create.
Yeah, removing these platform-specific obstacles is great, but I think one of the most valuable things about AllSeen and AllJoyn is the set of standardized interfaces that are defined within various working groups. The fact that you can define your own device interfaces, and it provides devices with a common language to express the functionality that they implement, and it provides applications a standardized way to discover different classes of devices and to interact with them as well. And as an example, let's say you wanted to build a smart connected smoke detector. This smoke detector would just sit around and wait for smoke to be detected. It's going to raise a notification, basically your house is on fire, and it might have a feedback mechanism. This smoke detector might also provide an interface if you're cooking in the kitchen and you have some smoke. Maybe you want to provide a temporary silence for that alarm.
Right. So this is a great example of an internet-connected device that AllJoyn would be perfect for, because this was able to expose the device metadata. It's able to have onboard Wi-Fi. You can update the firmware remotely. You can send notifications, and it allows itself to be controlled by some type of consumer app.
So using the smoke detector as an example, it's just a part of a really broad spectrum of hardware that makes up the Internet of Things. Everything from really low power, battery powered, resource constrained microcontroller sensors, all the way up to servers in a data center. And the AllJoyn platform was implemented with this broad spectrum of IoT hardware in mind. So going back to the smoke detector example, there's a couple different ways that we could implement the device itself. We could implement it as sort of an end node, which could be hardwired or battery-powered microcontroller-based platform, or it could be a little bit more intelligent. This smoke detector could serve hub-type functionality where other edge devices could connect to it and that kind of thing.
Right, and for resource-constrained devices, the AllSeen Alliance offers the thin core of AllJoyn. This is really good for microcontrollers. It has a very small code size. It has a C language that can work on anything that supports AllJoyn, which is almost anything. For your more robust devices, your hubs or your consumer apps, we have the standard core. This is based on C++. It also has a C offering for cross-plat, and then it has OS-specific offerings. Then on top of that, you have your UI and logic embedded into the device or the controller app, and you can go from there.
So you'll see there's a little UWP box. We'll get back to that later. The Universal Windows Platform part of this is really cool. So that's the core functionality. That's about connecting. It's about advertising. It's about discovering. It's about controlling, kind of the AllJoyn basics. But on top of that, AllJoyn provides a set of what are called common service frameworks. These common service frameworks implement a lot of the code that a lot of IHVs would typically write for their devices, or ISVs would typically have to write for their apps. Common device interaction functionality. Brian talked about our smoke detector and how it's likely to want to expose device metadata. It's likely to want to advertise which interfaces and what functionality it implements. AllJoyn provides the About interface for this functionality. The About interface is actually integrated into the AllJoyn core, but we're including it here because it offers functionality that sits on top of core. The notification framework could be used by our smoke detector to send prepackaged notifications that are easy to raise from a device and are easy to consume from an app or from another device, which we'll actually show you in just a minute. The notification framework also gives you the ability to provide prepackaged data, and there's even different severity levels. So you can send an information notification, you can send a warning notification, or an emergency notification, which I hope the smoke detector would send, because it's kind of important when your house is burning down.
All right. All of these common service frameworks are extensions upon the standard core in order to solve common scenarios for IoT devices. Onboarding, getting your device onto your home network, is one of these. We have a standard way through the All-Scene Alliance and through AllJoyn to do this with the onboarding service framework. So the smoke detector that we had is a headless device. It doesn't have Ethernet capability, but it's IP connected. It'll be able to act as a soft AP. You can connect to it, pass credentials, and it can get onto your network. Similarly, we have the configuration. If you want to factory reset your device, if you want to change its name, push for more updates, this is all available to you in a common way for every device, AllJoyn enabled through the configuration service framework.
So all of this code, AllJoyn in general, abstracts the platform specifics of the code that you're going to need to write. The core takes care of discovery and for advertisement and for interactions, and then these common service frameworks layer on functionality on top of that. The net of it all is that you can focus on the functionality that's specific to your app or specific to your device and not have to write it all from scratch, which is great. So let's talk about roles.
So I have a little bit of computer science background. I'm sure most of you do, and we're all more or less familiar with client and server. AllJoyn uses a similar nomenclature, but we use consumer and producer. Consumers are essentially your clients, and producers are your servers. Consumers connect to a producer, which is running a service, and this is generally your device. So in the case of some of these things on here, we have lamps that are running a service, and this is actually running the lighting service framework introduced by the All-Scene Alliance to make the smart connected lighting home a little bit easier to work with. So your lamps right here are producers, and the app that you would normally use to control it is a consumer. It can get a little bit more complicated with the apps being consumers and producers. For something like the lighting controller service, you have the with the lighting service framework, you have the lighting controller service. This implements different functionality and logic, such as groups and presets, and transitioning effects that you can use with your lights, and bundles that in a logic that you can implement in your app. So you can either have a lighting app that speaks directly to the lamp service in a bulb, or you could have a lighting app that speaks directly to the lighting controller service. And this is a way that an app could be both a consumer and a producer.
So I'm sure that's all clear as mud so far, but the basics are a device is typically going to be a producer, an app is typically going to be a consumer, and either one can be both.
Correct.
All right. So when we set out to build AllJoyn support natively into Windows 10, we had three primary goals. The first goal was to optimize security and performance, two critical aspects of any IoT implementation. We also wanted to provide the most seamless and best possible end user experience. And finally, we wanted to give developers a rich set of tools and integrations so that they could have the best possible workflow and bring their solutions to market in the shortest period of time possible.
All right, and I'm happy to say that we've met all these goals with bringing AllJoyn into Windows 10. We've managed to reduce the code size. We've increased security. We have libraries within Windows that you can link against so you don't have to bloat the size of your app. we've provided the router node service in box that allows communication between all the AllJoyn devices. You have any Windows 10 device on your network, you've enabled AllJoyn communication. We have invested in bringing the C API in box if you want to write cross-platform. We've invested in UWP language bindings so that you can write in the code of your choice, be it C# or JavaScript, C++, whatever you really are comfortable with. We're making integration with Visual Studio so that the time that you get your idea to you define your device to you write your app is seamless and quick. We're offering lots of samples. Go out, check the Microsoft GitHub. We have samples out there right now that show you how to set up your basic producer and your basic consumer. We have more coming. We're investing heavily. The AllJoyn Alliance also has several samples available.
All right, well, that all sounds good, but I think we should actually see some of this in action.
I agree.
Okay, so one of the great things about being a part of the AllJoyn Alliance is the partners that we get to work with. And we have here today a couple of the partners that have been really great innovators in their individual technology areas and have been great partners in the work that we've done for Windows 10. So the first partner that I want to introduce and bring on stage is a pioneer in the smart home industry. And they are implementers of extremely robust connectivity technology. And they have the largest portfolio of smart home IoT devices that are available globally. And they're also very active members of the AllJoyn Alliance.
Yeah, it's my pleasure to welcome Joe Data, CEO of Insteon.
Thanks, guys. Good morning. We're really excited to be here. This is really what feels like the launch of the fulfillment of a vision that we started 20 years ago. We've been investing heavily in building out, as you just heard, the largest ecosystem of products. We offer over 200 different products, connected products, and the technology that wirelessly connects them. What's exciting that we're hearing about and talking about this morning is industry titans like Microsoft helping us all to bring unity and interoperability between these devices. So we're very, very excited. And this morning, we're delighted to announce an Insteon AllJoyn-enabled version of our Hub Pro. So for the first time here in the last 5 minutes, our page just went live, so you can order these online. And during build, there will be a discount offered to all developers to purchase the product. The AllJoyn-enabled Hub runs the thin client version of the AllJoyn API. And it makes use of the speed and connectivity of your proximal network while you're at your home and the power of the cloud when you're away for alerts and notifications. It is pretty easy to develop against the AllJoyn API. I can tell you that versus the other platforms, I think that the AllJoyn Alliance has done a great job of doing a lot of the heavy lifting, keeping that off of us developers, and making it very, very practical to go from 0 to 50. In fact, we aren't just waiting for other developers to develop against this Hub Pro. We're eating our own cooking and also developing our own app. And with a little help here from my friends, hopefully we can turn a fan on and off using some of the inbox tools that come in Windows 10. What we've got here is an on-off, plug-in on-off module. Basically, it takes a dumb fan and makes it, adds connectivity to it. And so we can see the status of the devices as well as control them from the interface. And we will be taking these tools and then embedding it into our Windows application over the couple months here. And we are committing today to be shipping support for all 10 when Windows 10 ships. In just a couple months.
Awesome.
I'm looking at somebody else's notes here. Sorry. Sorry. We're really excited about where this is going. We're going to play a very active role in the AllJoyn Alliance and lead continue to lead the future and really connect all this, all these devices. The promise of the Internet of Things is a great one, but the challenges are real. But we feel confident that the All-Scene Alliance and the AllJoyn APIs are really going to be helpful in moving this forward. Thank you very much.
Thank you.
So the next partner that I want to introduce has been doing some amazing work advancing smart connected lighting technology. And we're on Kickstarter initially, and at the time of their funding, they were the highest funded Kickstarter project of all time. They also have the only Wi-Fi connected multicolor LED bulb on the market today.
It's my pleasure to introduce and welcome John Cameron, VP of Product from LifeX.
Thanks, guys. I'm thrilled to be here, and I can't wait to show you guys some of what you can do with AllJoyn. So at LifeX, we make these full-color, super bright LED bulbs. They plug into any standard light socket. And apart from being the brightest smart bulbs on the market, people love our bulbs because they don't need any other hardware. They're Wi-Fi, straight away connect to Wi-Fi without another hub or anything like that. As device makers, we believe really strongly in an open Internet of Things because we know that the real magic of connectivity happens when developers like you guys get hold of open standards that they can control everything that's connected and do things, amazing things that we hadn't even imagined. So we joined the All-Scene Alliance early on, and we helped build this lighting service framework, which is an extension to the AllJoyn core, and it's built around specific lighting scenarios like setting up groups, changing the color of lights, discovering lights, that sort of thing. And we've integrated the AllJoyn service into our product offering. We've recently launched it with our new white 800 bulb, which we're very excited about. So from our point of view, it's been really awesome to see masses of the world's leading hardware and software innovators joining the Alliance, and having Microsoft with their ground-up support for AllJoyn coming out in Windows 10, this really tops it off as far as we're concerned. So they've made it so easy for developers like you guys to be part of the Internet of Things. So I'd like to show you an app that we quickly built here. So we've replicated the functionality on our Android and iOS devices and quickly managed to make a Windows version. Now what's really cool about this is we can do the basic stuff like control our lights and their color, but we got all of this for free. We didn't have to do any of the complicated stuff that we've had to do in the other apps. Onboarding the device to your Wi-Fi, having the apps discover nearby devices and know exactly what it can do and what those devices' capabilities are. Do they display color? Do they not? Do they display just white? Those sort of things. We get all of that for free here. But the best part is we get that across all platforms. So here we've got the a Windows Phone demo, but we've now got that on. This will run straight away on desktop. I'm trying not to say HoloLens, but yeah, it's going to run on HoloLens, Xbox, and Surface. So we've got instantly been able to build this app, throw it together, and we can control our lights, discover our lights straight away on all of those different form factors. But there's more. We also get out-of-the-box support for all of the cool things that are part of Windows 10. So I can grab a light here and drag it to my start menu, and I've got a live tile that I can see the color of my light, or I can tap it to turn it on and off. But my favorite is we get Cortana voice control for free. So this is the first voice control app that we've had. So if the gods of internet connectivity work, we'll give it a go. Hey Cortana, turn my LifeX lights off. So that's going out to the internet. I'm going to try that again because there's too much Wi-Fi going on here. I don't have internet. Hey Cortana, turn my LifeX lights off. Here we go. So Cortana's gone out to the web, discovered what that message means, and with me doing nothing, we haven't had to do any special dev. I've just turned that off. come on, it's so cool. I'm going to show you again. Hey, Cortana, turn my LifeX lights on. So again, she's been learning my Aussie accent, and she's been doing pretty well. She gets it pretty much every time now. So here we go, LifeX light back on.
Awesome.
So to finish up, I want to let you know what this means to you guys. The Windows 10 AllJoyn SDK unlocks what we think is a completely new canvas for developers. So right now, you're able to discover and control lights that people might not even know that you have access to, but because if you've got Windows 10, you can control these straight away. So this gives you complete control of the ambience in a room. So your games can immerse players with real-time control of colours. Apps can set the perfect ambient mood lighting. And like these guys showed, even white goods and appliances can send a status alert to your apps or to lamps in a distant room and blink to let you know what their status is. So we can just imagine a gamer's delight when, for example, in your app it goes from daylight to darkness and the room lights dim, or when some green creepy thing comes along, the lights flash green. So we just can't wait to see what you guys do with this. It's so easy to do. And we're going to pass you back to Gavin and Brian to show you really how easy it is. Thanks, guys.
Awesome.
Thank you, John.
Yeah. So we have a couple more devices that I want to show you real quick. Just step down here. So you might be wondering why this TV is here. This is actually an in-market WebOS equipped LG TV that supports AllJoyn natively. And then I'm sure like a lot of you guys, I like to learn by doing. I like to get my hands on with stuff. So when I started working on AllJoyn, one of the first things that I did was I went and created this AllJoyn enabled toaster. Now you might be thinking there's a huge market here, right? But when I looked at putting this on Kickstarter, I found there just wasn't that big of an opportunity, but it does make a great hardware sample, and we're going to show you some apps that work with this as well. So this is a Raspberry Pi 1. I've implemented software for this both using the thin core and using the standard core. What we've got running here is a standard core producer that implements toaster functionality, and Brian has an app that he's going to show you.
Right, so we've talked a lot about the interoperability of AllJoyn, but we haven't really showed any interoperability. So here we are going to use Gavin's toaster, and we're going to go ahead and use some of these light bulbs to put a little bit of a demo together. So this toaster has some methods: start toasting, stop toasting. I can set the darkness of it. And
perhaps what I need to do is restart my producer here. There we go.
it's good.
Now if you relaunch, she should be good to go.
There we go.
And there we have the simulated heating element.
I get a toast when my toast is done. And my LifeX bulbs go ahead and flash over here.
And on the LG TV, not sure if you saw it, but we got a toast done notification straight out of the box, no additional integration necessary.
Yeah, now say this darkness goes to 0 to 10. What if I want to toast a little darker? I can go ahead and start toasting with super dark toast. It'll go on for a little bit.
Imagine smoke coming out now.
Things might get a little too hot. Oh no, I now know my toast was burnt. We get that same notification over there on our LG TV.
Yep.
And this app was simple. It took me about maybe an hour to connect these different devices. AllJoyn enables interoperability really well.
So we're going to write some code, right? Is it right time yet?
Not exactly yet.
Okay.
Almost, though. So I think we need to go a little bit over some of the high levels of how we've brought AllJoyn into Windows 10 and the tools that we have available for you. So the very first thing, if you want to go out and write AllJoyn apps for Windows 10, is you don't have to go to any third-party website. We've brought it all in box. It's all either in the SDK or in Windows 10. So you just go out, get the Windows Insider program. I think we have a new build today, maybe tomorrow. You get the tools, and next you have to choose your AllJoyn device. You can choose a device that already exists So we have the lights, we have the hub that you can order now. You can even create your own device. It's very simple. All devices are defined based on their interfaces. You can quickly write up your own. You can use our Windows 10 tools to generate code from it, because that just makes it easy. Then you hook up that AllJoyn functionality in your app, you combine the logic, and then you can build it. You can deploy anywhere. As you've seen from the keynote, we can go PC, phone, tablet, Xbox. It's all available for you. Then you can use our Windows store to distribute it across the 2 billion devices that Terry mentioned.
So at a software level, your AllJoyn Universal Windows app is going to look something like this. There's really two categories of code that you're concerned with: the code that you're going to be using and the code that you're going to be writing. So below the magenta box, we have all the code that we're going to be using. And at its foundation, we have inbox an AllJoyn C standard core API. This is the API that provides the functionality for your device or your app to be able to advertise interfaces that are exposed and implemented. And it basically implements all the functionality that's required for connectivity. So it's the foundation of AllJoyn. On top of that, we've built a proper universal Windows platform API. So it's got all of the type mappings and implements the patterns that you're going to be familiar with writing universal Windows applications. So this means that you can either have more low-level granular control if you need it, which you probably won't, or you can use our native UWP API for this core AllJoyn functionality to perform all of the fundamental AllJoyn tasks and activities.
Then you have generated code. You have a generated code component for each class of devices. So in my instance, where I had lamps as well as a toaster, I'd have 2 packets of generated C++ code that I would use in my app. This is this is code that you don't need to touch at all. We've generated it for you. The only time you actually need to change it is if you modify the interfaces and definitions of your device. In that case, you just need to regenerate the code. It's once again available for you. And then you actually use this code in your UWP app code. So use it from XAML, C#, HTML5, JavaScript, whatever language you're most comfortable in. We've made it easy for you to develop basically in whatever way you're most efficient.
So the code generator, walk us through how this works a little bit.
Right. So AllJoyn defines introspection data, and this is usually in the form of XML. You can get this several different ways. You can get it from a manufacturer's website. You can grab it from the All-Scene Alliance. You can even get it just from a producer running on your network. So all these devices, they're announcing their presence, and you can look at the different signals, properties, and methods that they expose and that they're capable of. You take this XML and you run it through our Windows 10 AllJoyn code generator. This will create all the code files necessary for making a controller app, our client or consumer app, or our producer code that you will implement in making a device.
So these are the manual steps broken down, and this is what we're actually going to walk through. But when we ship, we're actually going to have all this integrated with Visual Studio, so it'll be hidden from you. You won't even have to go through these manual steps. But in the meantime, we've actually prepared a blog post, which is going to go live in the next day or so. That's going to have all the code that we're going to show you, and also all of the manual steps that are required to go through this sequence here and some of the other sequences that are necessary in this pre-ship state for UWP AllJoyn integration.
All right. So going back to the combined demo I showed, we had a few different bulbs and we had a toaster. Each of those bulbs and the toaster were their own producers running on the network, and they communicate on the AllJoyn bus. This communicates through the router node that was built into Windows 10, and then communicates with the app, once again through the AllJoyn bus. For each class of devices, I have a watcher that sits on the AllJoyn bus and waits for a producer to announce its presence. Once it does, it joins a session with that producer, and I get a consumer object in my app that I can use to control that producer. So in the case of the 2 bulbs that I had over here, I had 2 consumers in my app. In the case of the toaster, I had 1 toaster consumer in my app.
The great thing about Windows 10 is this AllJoyn router that we're showing here is built in. So as a developer, you don't even need to think about it. It'll start automatically, it'll stop automatically, and it's just another way that we've been able to optimize performance. So AllJoyn is an extension of the Universal Windows App Story and the Universal Windows Platform Story. And because of that, you can write your code once. You can optimally supply a different layout, XAML or HTML, for different screen sizes or different form factors, and then target these multiple devices. We actually did this at WinHEC. We had a hands-on lab where we had a lighting control app. And we had the same exact code that we deployed to a Minoboard Max running Windows 10 IoT for devices and ran locally on the PC. It is really, really easy, and it's a really great benefit for developers.
Mm-hmm. Once again, this is all the promises that Terry made earlier. It's, if you want to make something that deploys everywhere, you can. If you want to write something that tailors specifically to a device, you're enabled to do it.
So let's actually show that process.
Yeah, let's do it. Cool. So one of the things we mentioned is that you can actually get the XML and the device data from the producers directly on the network. So why don't we go ahead and make a toaster controller app
Sounds
that
good.
does that. So we have a tool that we're going to be shipping that allows us to listen to the different devices on the network. So we go to that, and there's a lot there, so I'm going to exit out of that, and I'm just going to save this to a file.
And again, this is some of the detail that you won't even have to worry about when Visual Studio 2015 and Windows 10 ships. We're building it into our Visual Studio 2015 integration story.
Yeah. So I can go ahead and look at my devices that I have here. I can see that I have my Insteon UAP app. I have quite a bit of Insteon UAP apps, apparently. I have my combined demo that we showed. We have our LifeX bulbs. We have our LG TV. Did I see the toaster in there?
Why don't you search on toast, and I'm going to make sure our toaster's actually running. I'm going to restart here. Okay. So let's see. Okay, we're up and running. Sorry about that.
All right.
Now the great thing is we could basically take any of these devices that we have running on the network, and in just a moment we're going to show you how you can use this Get AJXML tool to pull the introspection XML for each of the interfaces here that are shown with their corresponding object paths. Oh, so I see you found it.
Yeah, so here we have it. That's an interesting model number that we have there. Any story behind that?
That's actually my birthday. That's funny.
So you can see this tool. It finds the bus name, which is the unique name that the toaster has on the bus. We have the port and we have the object path. So we can take this information and we can put it into our tool as arguments. And then we get the actual interface information. Once again, we're just going to stick this into a file.
Now here we get interfaces that we explicitly implement, and we also get interfaces that are implicitly implemented on our behalf. So we have some extra stuff here.
Yeah. So I'm going to get rid of that extra stuff for now because we don't actually need it for what we want to do with our toaster.
Okay, so we're using the toaster interface. That's what we have here.
So we defined our interface as a sample in the Microsoft domain. We have the methods, which is how a consumer interfaces with a producer or initiates.
Like RPC calls,
Like
basically.
RPC. We have two of those. We have start toasting, we have stop toasting. We have a signal that gives us a status when the toast is done. This is how a producer generally will initiate contact with the consumer. And then we have a property, darkness, which is a UINT that is read-write accessible. This is stored on the producer and can be accessed by the consumer.
And again, darkness property, 0, mildly warm, 10, burned, charred, black, may cause your house to burn down.
So we'll go ahead and run the AllJoyn code generator. We'll input the toaster XML. We'll put these in our CodeGen files folder. And as you can see, it's pretty quick. All our files are right here, everything that you need to get up and running.
So conceptually, I remember was talking about the common service frameworks and how they provide higher level functionality. The code generator essentially gives us something analogous to a common service framework, but something that we can have as a universal Windows platform component and use it directly from our app.
Right. So I'm going to go ahead and make myself a Toaster consumer project.
Hopefully, with this app, we can end the whole phenomena of cold toast, right? Because you got to get notified right away. And what if you want to cancel toasting while you're sitting on the couch?
So,
these are real world problems.
Yeah. As Gavin mentioned, we would generally take care of this for you with our Visual Studio extension and integration. But in the meantime, I'm going to go ahead and add in all the code that we had from the code generation. So I saved it all in this runtime, and I'll just pop that in there.
Some manual steps required here for the build that you guys are going to be working with. Again, we're going to have the blog post that will describe all of the manual steps here.
And here's all of that code that I showed you earlier. So the very first thing when you have your app, or the first thing we have to do, at least until integration, is we're going to have to add the AllJoyn capability. And this capability lets you tell your users, essentially, what capabilities the app has. It sets firewall settings. It takes care of a lot of communication for you. We'll go ahead and add a reference to the Toaster runtime that we added. And then let's go ahead and just try and build.
It's always good when the code builds. So this is basically where we've got all of our boilerplate code taken care of, and we're ready at this point, hopefully, to start writing our AllJoyn code, the code that actually uses the AllJoyn functionality.
So I'm going to go ahead and use the toolbox to go ahead and add some buttons that we will use to start and stop our toasting.
We're engineers, we're not designers, so please be kind.
Let's say I'll go use myself a slider. There we go. We'll change that maximum to 10. And then I'm going to clean this up a little bit.
Renaming our variables, I like that. The code will read quite a bit cleaner there. And again, we could use this UI right here that we're building in XAML on a variety of platforms for our universal Windows application. If you wanted a toast control app for Surface Hub that has a different layout, you can easily supply that layout and build that target accordingly.
All right. I'm going to go ahead and create an event when the value of the darkness slider is changed. So I'm going to call it, amazingly enough, darkness slider changed. And we go ahead and get the code in our CS file for when that happens. Similarly for the buttons, whenever you double click it, it'll create a click event. It's nice and easy for you. All right, so now we're actually ready to begin. We've mentioned the using Windows.devices.alljoyn namespace, so I'm going to go ahead and add that in.
This enables us to use AllJoyn. All of the resources and types that we're going to need are in that namespace.
Yep. If you look at the Toaster runtime project that contains all our code-generated components, we see the root namespace is com.microsoft.sample, same from our interface XML. So I'm going to go ahead and enter that there. Then it's time to go ahead and declare our variables.
So we're in main page. This is the method that's going to get called when our app starts up and the page loads.
Yep. So we know we need a Toaster consumer because we have one device on the network. We're going to need our AllJoyn bus attachment to do all that low-level communication. And then we have our uint for our darkness. So let's go ahead and initialize these. We'll create a new bus attachment. We'll set a darkness to a value of 5 to start off. Then I have a little helper class here for starting my watcher. So this watcher will sit on the network, and it's going to look for any toasters. When the toaster is added, it'll trigger a callback method, toaster watcher added, and that'll allow us to join the session. And then don't ever forget to start your watcher. So this is really easy to implement because it's just plus equals and then tab tab, and that gets added for you.
So if we have a device that's already advertised in interface, we'll find that right away. If a device comes by later, we will get this watcher added method called at that time.
Yeah. So in our watcher added code, well, first things first, we have to make it asynchronous because we're using asynchronous calls. So we have a join session result from when we try and join session with the toaster on the network. If that status is OK, we can go ahead and create our consumer, and we can go ahead and register for all the signals available. And I'm sorry, I see some people squinting. So we go ahead and register for the signals when it's done. And this is, once again, really easy. Plus equals tab tab. I think that one is generated. Yep, there it is. And in this, we can do whatever we really want. So let's go ahead and pop a toast when we have a toast, like before.
Sounds good. Action Center, right?
Yeah. So we have a little bit of red squiggles. Visual Studio makes it really easy to get rid of those. It'll add the using statements in for us. And that's taken care of right there. So when we join that session, the very first thing we want to do is initialize all our variables. So let me go ahead and create a set darkness. So async, of course.
I just love how Brian centralizes his code.
So we're going to go ahead and take our toaster consumer, and we're going to call the very hard method setDarknessAsync, passing in our darkness uint. That's all it's going to take to actually do that. Of course, I have to type correctly. And then since this is asynchronous, we have to await it. So that's most of the things taken care of. Now we just have to go ahead and implement what happens when the darkness slider changes. So we'll go ahead and take our darkness, and we'll cast it as a uint. And then once again, we have to change these to asynchronous methods.
The consumer is a part of that generated code. It provides us a very easy to use UWP interface that pretty much maps identically to the introspection XML, but with UWP semantics.
Cool. So now that we have everything there, let's go ahead and run it. And we should get ourselves some toast.
Nice.
So let's go ahead and set that to, I think we might have lost our toaster.
All right, toaster's acting up today. Okay. I just kicked the toaster.
I'm not getting it. There we go.
Yay!
So yeah, we get that. We got our toast done. We can go ahead and see that in our Action Center along with all the other notifications that we got. We can clear that out. So yeah, it really is quite simple and not a lot of code at all to write a Windows app using AllJoyn.
So the code that we're going to link to from the session page for this session will actually also include a basic implementation of a toaster producer. So what would be cool would be to write a toaster producer implementation, something like what we've shown here. And again, we'll have a link to that in our session page. So earlier, I painted a utopian picture of the world. The AllJoyn slide with all of the pink dots. Every app knows about AllJoyn natively. Every device implements AllJoyn functionality natively. But we all know that that's not reality. There's always going to be a composite of different protocols or different implementations, different APIs. The good news is Microsoft has been working on and has contributed back to the All-Seen Alliance something called the Device System Bridge. This Device System Bridge makes it really easy to take non-AllJoyn devices like Zigbee, Z-Wave, and BACnet devices and to expose these devices as virtual AllJoyn devices on a network. And there's two key benefits here. One is the AllJoyn interoperability story. If you're already adding AllJoyn support into your UWP app for Windows 10, you're going to be able to discover and interact with the devices that are exposed through this DSB. One of the other key benefits is the fact that we can enhance security. If we have devices that are inherently less secure, we can add layers of security on top of the virtual AllJoyn devices that are exposed off the DSB. So if we need credential exchange or encrypted data traffic, it makes it very easy to do that. Now, Kira Richardson is going to be giving a talk here at Build. It's the very last session on Friday. If you want to know more about the DSB and IoT stuff, I would encourage you to check out her talk.
So, as Joe Data announced, Insteon's coming out with their app and their hub. It's available right now. We have our Visual Studio integration that we'll have available soon, and we have more AllJoyn samples coming. We talked about the different common service frameworks. We'll have a sample that shows you how to onboard a device, as well as a sample for how you receive notifications. Then we also have the existing samples that we have that show how to create a producer and a consumer, how to create signals, methods, and properties, and how to implement security.
So we've had a lot of fun working on AllJoyn and getting our hands dirty with AllJoyn. We want to invite all you to do the same. And what you can do today is install Windows 10. You can build AllJoyn-enabled UAP devices and apps, and the code that we're going to link to from this session page is a great way to get started with that. But we would really love to hear your feedback, because we want to know what the developer experience is like. What did you like? What didn't you like? What was missing? What was great?
More than that, get involved with the All-Steam Alliance. We've mentioned it's open. Anyone can join. There are several different working groups that you can help to drive and define the future of different workspaces, whether it be appliances, whether it be lighting, whether if it's just the common service frameworks. It's open, you can contribute your code back, and you can help define the shape forward, especially in relation to device schemas and introspection XML for different classes of devices.
Absolutely. And with that, we'd like to open up the floor for questions. We actually have a couple microphones here. If anyone has questions, you can file your way to the aisles, come forward, and we'll handle those questions now.
Yeah.
Are you implementing the data-driven APIs as well as the other ones?
Can you elaborate on that? The question was, are we implementing data-driven APIs as well as the other ones?
Yeah, well, you have the publish-subscribe APIs that are that go beyond just your alarming events for sending normal data streams up.
So we have everything that's available with Windows 10. I don't think AllJoyn has anything specifically around data-driven APIs.
Yeah, it's basically the producer and consumer semantics that we talked about in any of the interactions that we described with, RPC method calls, being able to set properties. You can actually get notifications on those changes, and then signals. And then the notification framework, which the Toaster actually implements support for, is one of those common service frameworks that sits on top of signals, essentially. Yeah.
Yeah.
Yeah, is the code run on the Pi.net or something else?
This code here is running embedded Linux, and this is the standard core running on embedded Linux. There's also a thin core version that I also implemented, but you can develop similar device implementations using Windows 10 IoT for small devices. Yep. Sorry, say that again? Activation happens automatically, did you say?
No?
Okay. Okay. Any other questions? Yes.
Your slides, I saw the LifeX LCM engine that was on their command line, I believe. Is that a special engine you built?
John, do you happen to know about that? LifeX LCM engine?
Yeah, so the LCM is a low-cost module that we've built that any LED ability and Wi-Fi ability. So there must have been some reference to that.
Okay, great. Any? I can get that for you afterwards.
We have a
actually.
link to it. I
Yes,
think, actually on the
actually,
slide.
good point. This is a great transition. So these are just a few of the sessions that are going to be relevant.
So yeah, concurrently to right now was, do we have that on here?
The DSP one, just to go back to that, was 752.
Gotcha.
You might not be able to tell from the title. Say again, Brian?
The OSS one? Do we have that link to?
Yes, 617.
Okay.
That's actually happening right now, so unfortunately you'll have to view that one online. But our friends in MS Open Tech are giving an overview of all of the open source work that we're doing, which AllJoyn is part of.
AllJoyn is the largest open source software currently in Windows, but we're basically paving the way to bring more in. And if you're interested about different open sourced code bases joining Windows 10, go look at that talk after you leave here.
Yep. And as we mentioned at the beginning of the talk, if you could take a moment to give us your feedback on the session, that would be awesome. And Brian and I will be available for just a couple minutes down here in the front.
Yeah, and then
if you
we'll
have
be
any
at
other questions.
the Windows Insider section.
Of course.
Yep.
So come around the corner and talk to us then if you have more.
And
in-depth
then,
questions.
so Drew over there is our partner guy. Please, if you want to, talk to him. He'll be having some meetings after this.
Thanks, everyone.